Okay, we're going to be looking today at how to write an expression to represent the number of cubes in a figure. So in figure 1 here, I have 5 cubes. So figure 1 is 5 cubes. And then I notice on this one that they've added on one more to each of the 4 corners. So I know that that one's going to be 9. And then I could count them 5 here, 6, 7, 8, 9. Then this one here, I see they've added on one more again. I could count them if I wanted to, just marking them off, or I can just realize they've added on 4 more, which is going to be 13. So I can see going down this side that each time we're adding 4 more. So without even drawing the next figure, which if you wanted to, you could draw it with dots, something real fast, if that helps you. I know that it's going to be 17, and that's faster to me than drawing it. And then when I'm writing the rule, it also helps to think of what it would be at 0. What was there at the very beginning? This could be even a negative number. In this case, we're going to work backwards and try to figure out what number, when I add 4 to it, would get me 5. Um, so I'm just really doing the opposite of adding 4. I'm going to subtract 4. And this gets me 1. 1 is the number that when I add 4 to it gets me to 5. So when I'm writing my rule for my expression, okay, this right here, whatever the number is there, is going to be this number right here. What are you adding each time? What are you adding each time? So there's the 4. And then this number right here is the 0 value. What did you start at? What was the amount of boxes that would have been in figure 0? So figure 0, if we can think of it, would have had just one box right there. And then in figure 1, for the very first time, we added the 4 to it. What's weird is that this number could even be a negative. Maybe you were missing some in the first one when you go back in the pattern. When it gets to be a negative or a minus right here, that's when it confuses kids. So the 4 is the number going down the side of the chart. This number here is what number would have been across from 0. If you can think of figure 0, what number would be across from it? So that's that number right there. Maybe I need a bigger arrow. And you can kind of prove that it works. So let's look and prove this, that when we plug in 4 for the n, let's see that we actually get 17. So that would be 4 times 4 plus 1, which is 16 plus 1, which is 17. So I kind of proved to you that it worked. I tried doing that one for n equals 4, figure number 4. Here were the examples that we'll be going over in class. So I've already filled these in. And so we'll see here that we have a star pattern going. So here's the 3, here's 5, here's 7. And I did stars, but I would probably just put a bunch of dots to simplify this. And I've noticed that I was adding a star to the top and to the side each time. So I was adding a star here and here, which is adding 2 stars. So eventually I just realized that my pattern is add 2 each side. And then again, just like on the warm-up problem, I thought, what number when I add 2 to it would give me 3? So I realized that the starting number, the constant, is 1. So the 2 is the number of stars you're adding each time. The 1 is the one you would have in that corner right here, that one in the corner. You can find that number by what number would be across from 0. What number would be across from 0? So I'm going to ask you to prove that your rule actually works. I asked you to plug in a 5. So we know that when we put in 5, we should get 11, and we're showing that the rule works. When I plug in 5 for the n, I work it out, I get 11. When I plug in 20, which I wouldn't want to do this, I wouldn't want to draw figure 20. I mean, I could, but it would take me forever. What would you get? And I would do 2 times 20 plus 1, which is 41. Okay, let's see. Here's one of the U tries that student did. I got bored of drawing the figures. If you wanted to overly simplify it, this is this figure, so do one more. And notice one more. I'm just doing dots because it just goes faster than drawing the boxes. And so explain in world how it's growing. I would say that it's adding 1 to the side, the top, and the side. You're adding 3 each time. Left, right, and top. And you'll see that that add 3 each time shows up here. Where did I get this number from? I counted 1, 2, 3, 4. Figure 1 had 4. Figure 2 had 5, 6, 7. Okay, you can't see what I'm doing. Here's where I found the 4. 1, 2, 3, 4. Here's where I found the 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I'm filling in the first couple parts of the chart, and then I just build the rest of the chart off of it. The 3 is the repetitive addition. The 1 is from the working backwards. What would have been the pattern for that corner? Let's look at, here, quickly look at this one. This one we're adding 3. You'll see the pattern is growing in the middle. It's adding 3 each time. And this time, when I worked it backwards, the number that worked back here was a 2, because 2 plus 3 is 5. This number came from here. And I thought to myself, if I added 3, what number would have been here? Okay. You can see that I've proved that my rule worked by showing that 5 gave me 17. I showed what I would get for 62. Here's the last one. You'll notice on this one, which is the first little funky one, that our 0 value is kind of like it has a negative number on there. So you'll see that just like in another pattern, we see that we're adding 2 each time. We added those 2, we added those 2. So this one would be like 4 down and 4 across. So figure 1 had 1, figure 2 had 3, figure 3 had 5, figure 4 has 7, and I just build the rest of the chart. I'm adding 2, and I'm thinking here, what would have had to been here? I am thinking backwards. What number, when I add 2 to it, will get me to 1? Okay, so here is the repetitive addition, and this right here is the negative 1. Okay, why is there a negative 1 here? Because the 0 figure was actually kind of short one. And that's a little bit confusing that you can be short where it started off. It wasn't until the second figure where we started adding 2 each time. And that's where this rule, which is equivalent to, comes into. This one I think is the one that you should stick with. But this one says we didn't start adding 2 until the second figure. Okay. And you'll see that I proved that it worked by plugging in 5 and showing that it gets me 9. And I could use my rule to figure out the 20th figure by plugging in 20 to figure out that the 20th figure would have 39 of those little dots in it. You could draw it out if you wanted. Just realize this is the repetitive pattern. This is what the table says would be across from 0. You can do it. You can do it. Practice a couple and you'll get the hang of it.